Hello everyone, my name is Mingxiao Guo. I'm demonstrating my personal project on cmpe281. As you can see, here is my AWS EC2 console. Here I launched 4 instances. This one is a jump box which can access to the other 3 node, and this one has an public IP, and which allowed me to upload my project file into the system and deploy them. And this instance is a master node in my system, and notice that there is no public IP, and this too is slave node in my system, and they also don't have any public IP. So let's look at the security group. The security group I use to create an instance is this one, and I open 80 port and 880 port and 22 port for the project purpose. We do the REST API through the 80, and when the load balancer route into the system, we use 880 to communicate within the system. So let's take a look at the load balancer. I have one load balancer, and which has 3 instances under it, and all of them are in healthy status. And notice that there are 2 slaves and 1 master. Okay, let's look at the VPC. The VPC I have is 1, and for the project. So under this VPC we have 3 subnets, which is also available at all time. And the security group is the same for creating the instance. So in order to implement the CP network partition, I use the network ACL. So if we, like this, deny this IP address, let me just change to allow. If we deny this, the certain IP address, we can assume that this node binding to this IP address is partitioned from the host system. So which means this node is in network partition, and the host system will become a CP system. So let's look at the load balancer and we copy this DNS to here, and as you can see, I deployed Tomcat to my 3 instance. I deployed the Tomcat through the jump box to the 3 nodes, and as you can see, here is the private IP of the every node. Here is the master node, which has 0, and if I refresh, this is the second node and second slave node, which has 2. This is the slave 1 node, which is 1. So I can access to anyone among the 3 nodes anytime. So right now, let's test the system when it's under a health condition. So here is, let's make the short. So this is the load balancer DNS And let's do a post on our system. The key is 111. The value is hello. Oh, I'm sorry. Let's yeah, I do the test before, so maybe this key is already exist. So let's do another one. And let's post another one, so it will get the conflict. Yeah, here we post ID1 and the value is hello world. So the status we have in response is post successful, and the response is coming from the slave2 node. So which means we reach the slave2 node and we successfully write the key value pair data into our system. So if we do a get, we can access from any node and we can get the key value pair data correspond to the ID1. Let's do get and ID1. And here we can see we can get the data from slave 1. And let's do another one. This is slave 2. And this is also slave 1. And this is the master master node. So we can get all three nodes data. And so this is post. And let's do a put. So if we change the value of ID1 to, let's see, so if I change the value in to any of the node, it will automatically change send the request to the master if the node is slave. If the node is master, it will automatically route the request to the slave node. So let's do a put. Oh, sorry, I should not. 81 and yeah, we do the put and we get the put successful from the slave 1. So right now in our system we should have ID1 correspond to I love coding. Let's do it. Get and yeah, here is the master node and we also can see I love coding, and this is the slave 2 and the value is the same, I love coding. So let's do a delete. So we delete the ID1. So if the system working correctly, we should delete all of those data in every node. Let's do this. Yeah, we have the response says we successfully delete the ID1 and it coming from the slave 1 node. And we can get ID1. So in this situation, we cannot get any value from ID1. So it will respond as key does not exist. So let's see. Yeah, here we reach the master node and key does not exist. And the slave 2 node, also key does not exist. The slave 1, also key does not exist. So here is the REST API call from my healthy system. So right now I'm going to partition my system into 2, and I only want to partition 1. Here is the first slave node. I want to partition that, so I choose to deny this IP address and save it. So we should maybe wait for 1 minute so the Amazon will make it work. So remember, from outside, we can still access to the free node, but inside, in the internal network, the sleep one cannot communicate with with other node. Sleep 1 is partitioned. It cannot communicate with master and sleep 2, but we can access to the sleep 1 from outside. See, here we can see this is master, and we can also reach our sleep 1, and this is master, and yeah, cannot reach 2. Doesn't matter. Okay, so let's try. Let's see whether the system is partitioned. Let's do a get. If the partition mode is on, we reach the sleep 1 node, it will return us partition mode, and we cannot reach the node. Okay, the system is still not partitioned. We still have to wait. Let's check for one more time. Let's see whether this is denied. Yeah, this is denied. Let's run this again. Let's get. No, it's not. Still have to wait. Let's do it again. Yeah, we reached the partition mode. So in this mode, we will do a post first, as always. So we post ID2, and I say, I love cloud computing. Alright, so if we reach the sleep 1, which is under network partition, we cannot write this message into our system. If we reach other node, we can write this message into system, but we cannot read from the sleep 1 node. Let's do this. Sorry. Alright, so we reached the sleep 2 node, and sleep 2 is healthy, so we are able to post this message into our system. So let's first do a get, see ID2, I think, to see whether this information is in our system. Yeah, if we reach the partition node, of course it cannot be reached. So this is master node, and we can see I love coding. I love cloud computing, and this is the sleep 2 node, and also we can see this. So let's do a post. Hope that we can reach the partition node. Let's do good. Okay, let's hope that we can reach the partition node. Sorry. No, we still reach the sleep 2. Let's do ID4. Let's make it short. Apple and send. Yeah, we reach the sleep 1, which is under network partition. So we have this partition mode error. So if we get ID4, we cannot get any information from there because there's no write request processed by the whole system. So if we get the ID4 from the sleep 2, it will tell us key does not exist. And also 1 is partitioned. and the master also have the response key does not exist. So let's do a put. Let's change Apple to maybe Google, and we update this information and let's see what happened. Okay, now we reach the slave 2 and we update this information successfully, and we can do a get ID 4, right, and send. We reach slave 1, and we cannot read from the node. So let's try again. Still 1. Yeah, as we can see, the master node is changed, and also the slave 2 is changed. So let's do a put, and let's change for let me see, 3. Yeah, I remember 3 is whatever. Good. So if we can reach the, yeah, let's do 4 and we change it to good, and let's see if we can reach the partition node. We cannot process this update operation in our system. So if we get ID 4 from other node, it should return us Google instead of good. Let's do this. Let's hope that we can reach the slave 1. No, we cannot. So right now I change back to Google, and let's hope. Yeah. Right now I want to update the ID 4 to Google, but I reached the slave 1, so it refused to make that update. So if I get ID 4, so it will return me good instead of Google. Yeah, here is the master node, and it returns good. And also the slave 2 returns me good. Okay, so let's do a delete. So we don't need the body. So if we do delete, if we do this on the master node, and of course we can do this successfully, and we get ID 4 from other node. Yeah, condition the partition mode is cannot reach, but the master node key does not exist, and the slave 2 also have key does not exist response. And if we delete let me see, ID 1. Let me just get first ID 1. Let's make sure that ID 1 is in our system. Yeah. No. ID 2. Yes, ID 2 is in our system. And let's delete ID 2. Let's hope this request reach the partition node. No. Let's try another one. Let's get first. Yeah, ID 3 is there, and we try to delete it and see if we can reach the slave 1. No. Okay, so let's post let's do a post a new value, ID 4, let me see, 111. Let me see, computer, let's put this. Oh, 11 is already exist, so let's do a delete 111, and let's hope we reach the first slave node. No. Let me see, we can 1, 2, 3, and computer. Yeah, key is already okay. Let's do delete on 1, 2, 3, and let's hope. if we reach the 1, 2, 3, if we reach the sleep 1, so this one cannot process, this operation cannot be processed, and it means that 1, 2, 3 is still in our system. Let's do a get. Yeah, we get the sleep 1 does not cannot be reached. Yeah, and here's sleep 2, and we can get the information back. Also the master node. So here is my system running under the network partition. Implement the CP, and let's recover from the partition. So what we need to do is allow this inbound rule and save it, and then wait. Just try to get from, let's see, here we are still in the partition mode, but after we recover from the partition, the sleep 1 will also have the 1, 2, 3 corresponding value in the system. So let me see. Yeah, so the sleep 1 will also have hello world in this situation. So let's try to send. Here's the master node. Here's the sleep 2 master. Yeah, the network is recovered, and we can see the sleep 1 also have the hello world information. So this is my project. Thank you for watching.